now.
Hey everybody, my name is Mark De La Rosa. My ID number is 464-99661. And I'm going to go over several portions of the code. Starting out with this portion right here, average DHT, weather station, local station. We decided to create maps or dictionaries in order to simplify accessing these several different variables, some T, some H, ETO temp, for these different values for either the average DHT, CMIS, or local. And the two functions I'm going to discuss are going to be getDHT and print2LCD. GetDHT starts a thread timer, which will restart the function every 60 seconds. Continuing forward, we have this while statement, and what it does is that it checks through and reads all the values and determines whether or not it's proper. So for instance, every now and then there will be a -999 value, which is something we wish to throw away. We will only continue when we've read a proper value. Once that occurs, it will be stored in local. Temp is going to be assigned to what the DHT reads for temperature, and likewise with humidity or hum is what the DHT senses for humidity values. We have this rolling sum count. We add every one time. We have once. It'll keep counting up until 60 minutes, and that's finally when we will start to average out the DHT values and store them into these respective values for the map or dictionary. Next, moving on to the print2LCD function. This is handling the text that prints out to the LCD states. Starting with the first one, it's just the values that we get straight from the sensor, as shown with local, with humidity and temp. Next, it goes into the following elif statements, which then shows the average values, print from CMIS, for the humidity and temp as well. Then finally moves on to the third state, which is the DHT values in CMIS that we calculated ourselves. Finally, on to the fourth portion, which is the humidity for the watering factors that we get from averaging the DHT values as well. And if the humidity is equal to or greater than 1, we'll say water, if not, or we'll say water less rather, if not, water more. And then it goes to state 1, then finally restarts the thread every 5 seconds, which will then roll back to the first state.
Hi, my name is Sean Santorciero, student ID 530619226, and I'm going to be going over the web crawl part of our project today. And I broke it down to a few functions. I used a Google Chrome driver called Selenium, which pretty much automates the clicking process of going to the website. Here is the first function I created called login. This essentially puts in the password and the username. Clicks login to get the report. Then we go into prompt report. This fills out all the information needed to generate a CSV report. And then finally, I relate this back to our current time and our current day and extract the values when possible. And so here is the code running. And so as you can see, it opens up the window, CIMIS. It does take its time due to the slow internet. Types in the password for us, as you can see, no hands. And password, username. Logs in for us. Hits the tab data, and now goes into the correct screen. And so here's the report screen. It's going to choose hourly. It's going to cycle down to the ID 75 for Irvine. And so now it's going to go into the options to put in the dates. which will take 1 minute. And so there you see, it goes from 6/10/2019 to 6/10/2019, CSV report. Creates the report in a CSV file, downloads it. My code now takes that CSV file, opens it up, finds the time of the previous hour. If that value is available, I take those values and extract it. And so as you can see, here is the web crawl values. We have ETO of 0, humidity of 73, and temperature of 70.8 for the previous hour, which should be 2100. So let's go over to a CSV file or not a CSV file, a report generated just moments ago. And as you can see, 2100 is right down here. And the values we extracted were 78, probably can't see that too well. Can you hold that real quick, actually? Perfect, back over. As you can see, we got air temperature is 70.8. We have humidity as 73 and ETO as 0, which perfectly matches the values we got. And that is how our web crawl works.
Hi, my name is Sean Kerr. My student ID is 45774632, and I'm going to explain to you portions of the code today. And here is the getETO function. We check to see if we have a value in the DHT sensor for humidity to calculate the humidity factor here, and we use the average humidity divided by the CMIS humidity factor to get this value, and we calculate the average ETO here using that humidity factor. And then we move on down to get water. This is where we're going to water the function and measure for motion. Here we have all of our parameters that we use for the equation provided in class. So here's the equation we used in class that we calculated using the ETO from CMIS. Here we're dividing by 1020 so that we are watering once an hour, and then we're multiplying that number by 3600 to convert it to seconds. And we're going to run a while loop. And in this while loop, we are going to output Hive to our water relay. And we're going to sleep so that we're counting, and we're going to decrement our amount of time that we're watering. And so this sleep time is just to calculate for seconds how long we're supposed to be watering. And while we're in this while loop, we're going to detect for motion. So here, if our motion sensor pin is high, we're going to set the water relay to low, and we're going to display on the LCD motion detected, and we're going to sleep for 2 seconds to allow the LCD to show motion detected, and we're going to sleep for an additional 30 seconds. To turn off the water supply. And up here we have a start function and an end function, and we calculate the entire hour minus the time that this whole function ran, and we pass that into the threading timer to calculate a true hour. And then finally down here we have average DHT. And this is where we use sum count, and we're going to calculate if it's been 1 hour, and if it has been 1 hour, we're going to calculate the average temperature, average humidity, and we're going to reset our sum count and reinitialize sum H and sum T to 0. And here is where get water is called. So start watering key is a global variable set to 0. So the first time this runs through, this will be true. And we will set it false so that this will not get called in the future. This is only called once, and then which starts the threading for that process. And here in our main, we have initialized and called all of our functions provided.